we're done with this first worksheet with this one right here. So practice number sheet number 1, problem number 5, our last one for this worksheet. So we're going to go ahead and explain how to do it. Hopefully you already came up with the right answer and you're just figuring out whether or not you did it right or not. So, hey, one thing, let me know if I made a mistake. So let's go ahead and do that. Here's our steps again. As always, they're right here right now, at least for these ones. And so we're going to write the skeleton equation, then we're going to balance it. That's the first thing. So let's go ahead and read the equation. When zinc chloride combines with ammonium phosphate, those don't need to be there, it produces zinc phosphate and ammonium chloride. How many grams of zinc phosphate will be produced if 5 grams of ammonium phosphate was used in the reaction? So let's go ahead. So let's just break this right now. So we have zinc chloride combines with ammonium phosphate. So zinc chloride. Now, one thing about this is we have to determine what are they. Now, I know the charge of zinc is a +2, and chlorine is a -1. So they don't cancel each other out, so it's not a 1-to-1 ratio. So all we have to do is crisscross. And so that means we're going to put a 1 here and a 2 right there. And again, we can go ahead and put subscripts in there. So we go ahead and do that. So we did that. Now let's go ahead and do ammonium phosphate. Well, ammonium phosphate is, and we'll double check these charges. Ammonium phosphate is a +1. So it's a +1. And phosphate, I believe phosphate is a -3. Well, before we do it, let's go ahead and double check that. So let's go to our sheet here, and we're going to go ahead and we're going to scroll down to page 14 to get our first one, because that's a type 1. Okay, and so once we get down to that one, okay, so we have zinc +2, chloride -1. So there's our that. Now what about ammonium phosphate? Where do we find that? Ammonium is not an element, so we need to make sure that we go to our polyatomic ion sheet. In phosphate, it ends at 8, so we know it's polyatomic. So let's go to our very last page. Okay, let's see what we got when we get to that last page. Okay, here's ammonium right here, so it's a +1. And phosphate's right over here, and it's a -3. So we were good on that one right there too. So again, that's how we check them. We go to those sheets, we'll find out. So we know what that is. They don't match. So when we get back to here, these do not cancel each other out. So we're going to crisscross them again. So we're going to put a 3 here, and we're going to put a 1 over here. Now again, I like to go ahead and make sure that we have a subscript for those. So I'm going to go ahead and write those out. So let's go ahead and start the first part. We're going to start off with zinc chloride. So I'm going to put ZN for zinc. And there's only one of them, so we don't put that down. And then we put Cl as chlorine, and we need a subscript of 2. Now we have to go to ammonium phosphate. So that's going to react or combines with ammonium phosphate. And ammonium is NH4, so NH4. We'll go back to this though and make sure it's H. But I need how many of them? Yeah, I need 3 of them. So what do we have to do? We have to put parentheses around them. Okay, so we're going to bring that back up, and then we're going to put a parentheses, and we said we needed 3 of them. Okay, now we have phosphate. Phosphate, if you remember what it was PO4, so PO with a subscript of 4. Now, I only needed 1 phosphate right here, so I don't put parentheses around it. So that's going to yield. And as we go back to this, it yields zinc phosphate. So now we have zinc as a +2, phosphate is a -3. So that means we need a crisscross. So zinc becomes a 3, and phosphate becomes a 2. Okay, so we're going to put that in there. So we said zinc phosphate. So we're going to put Zn. I need a subscript of a 3. And then I have 2 phosphates, which means we need to put parentheses around it. So we're going to go ahead and put parentheses. It's going to be PO4 parentheses. And then we have to put a subscript of 2 because that's how many we have right here. And we figured out how many we have. So we're going to put a subscript of 2. And we have ammonium chloride. Now, ammonium, if you remember, was a +1, right? And chloride was a -1. So we only have, or we have a +1, and so they cancel each other out. So it's a 1-to-1 ratio. So we're going to put NH, subscript of 4. And then we're going to put chloride, which is Cl, so ammonium chloride. So right there, there is our skeleton equation, our unbalanced skeleton equation. We may want to double check, and I suggest that you always double check your elements. Okay, +2, -1, crisscross, that one's good. +1, -3, crisscross, that one's good. Okay, +2, -3, so +2 times 3 is +6, -3 times 2 is -6. They cancel each other out. And these ones here, there's one of each one, +1, -1, they're already good. So there's our skeleton equation. So now what do we have to do? We have to balance that skeleton equation. So we're going to go ahead and we're going to put down all the elements that we have on each side. So we have zinc, we have chlorine, and now because we have the ammonium and phosphate on each side, if you remember going back to balancing equations, we're going to cheat a little bit here and keep those together. So we have NH4, and then we have PO4. And we have, if we go out how many we have one of them here. On this right here, we have 3 of them. See, that's a subscript for that. We don't go by this one. That's just for the hydrogen. For the whole polyatomic ion, we have 3. Chlorine, you notice I have 2. And zinc, we have 1. Now, if you don't understand that, question it. Ask in class, ask in our Zoom meeting or our Google Meets. Figure out what we have. So that's what we have on this side. On the other side, let's go ahead and go to the other side. We have zinc also. We're going to go ahead and put down our chlorine, and we'll put it in this order. And the reason we're going to put it in this order is so they stay across from each other. NH4. And our next one is going to be PO4. So how many do I have? It looks like I have 3 zinc. Chlorines, I have 1. Ammoniums, I have just this one right here. Remember, this goes with it. It's not 4 of them, it's 1 of them. If I have more than 1, it's in parentheses. So we have 1. And our PO4, I do have that in parentheses, so I have 2 of those. So we're going to put down 2 right there. Okay, so I have each one. You can see what I have. So zinc, I have, they're different. They're different. They're different. Okay, what do you want to start off with? Well, I like starting off with the non-polyatomic ions because they tend to tell me, or they tend to work out. But some people like to start out with the polyatomic ions. Okay, and then the other ones typically will work out from there. But we're going to go ahead and we're going to start with, let's go with zinc first. So I have zinc right here. Okay, and so I have 3 on this side, I have 3 on this side, or 1 on this side. So I can only change the coefficients if you remember. So we're going to put a 3 right there. That means now we have 3 zincs. I'll get rid of this. But we also have, we changed the chlorine. So I have 2 times 3 is 6 chlorine. So now I have 6 chlorine, and we'll get rid of this one. Okay, so now I can come over here to the chlorine, and I can put a 6 right here in front. I can put a 6 in front of that. So now I have my 6 chlorine over here, but I changed my polyatomic ions. I have 6 polyatomic ions, so I'm going to go ahead and get rid of this, or put that over and put 6. So I'm going to get rid of that now. And I didn't get rid of this one, but I can now get rid of it. I'll do that. Okay. So now I'm balanced there, but look at, I got to chase it over here. Now I got to make it 6 over here. So I have 3. So what coefficients times 3 equals 6? Well, you're right, 2. So we're going to put a 2 there. That means that this is now 6. Okay, so I can get rid of this. But I also changed the number of phosphates. So now I have 2 phosphates. And if I go ahead and put that in, put 2 phosphates now and get rid of this one, I have 2, and that worked out that way. So there we go. There's our molar ratio, which is 3 to 2 to 1 to 6. So I'm going to write that in there. 3 to 2 to 1 to 6. Now, I didn't put molar ratio or anything else in there, but I do like to make it bold and change the color of it. Now, I always got to look at it. Can I reduce that? Well, because I have a 1 in it, we can't reduce it. So there's our balanced equation for when we need our molar ratio. So let's go ahead and go back to what we need after that. We're going to start our problem, and we're going to use the mass that's in the problem. Well, 5 grams. Well, 5.00 grams, which means it's pretty accurate. But how many significant figures? 3. The zeros are significant. These zeros are significant because of the decimal, if you remember. Nope, didn't change it to that. So because of the decimal, those trailing zeros are significant. So we got to have 3 significant figures in our answer. So let's go ahead and go down here and start with what we have. So we're going to start with 5.00, and that's going to be grams of ammonium phosphate. Now, here's ammonium phosphate. And I'm going to copy that. Oops. I'm going to make sure I get the whole thing. And the reason I'm going to copy is because I think it's a little bit easier to go ahead and do this. So we're just going to paste that down there than having to type it all out. Okay. So now what are we going to do? We're going to put our handy dandy times in line because we're converting it. So we're going to put times in a line. And again, what are we going to put on bottom? We're going to put grams on bottom. That means we're going to put moles on top because we're using our molar mass. We're going to use molar mass. 1 mole of something equals that. And since we're going to put grams on bottom, we're going to put 1 mole, okay, of ammonium phosphate. So we'll paste that again there. Okay, and we're going to underline that. So we're going to go ahead and underline that. And now we're going to put grams on the bottom. Well, we have to figure out the molar mass of ammonium phosphate. So how do we do that? Well, let's go ahead and do it right over here in this space right here. So I'm just going to put this over. So we have nitrogen, and we got to put all these down. Okay. Then we have hydrogen. We have phosphorus. And we have oxygen. Okay, so we have, there they all are. And I don't know. Okay, so there we got all those ones in here. So how many of each one do we have in this right here? So let's go to nitrogen. How many nitrogens do we have? Well, we have 1 times 3, so we have 3 nitrogens. We're going to multiply that by the molar mass of nitrogen itself, which is 14. Okay, let's do the next one. Hydrogen, I have 4 times 3, so we have 12 hydrogens. Multiply that by its weight, which is 1. Then phosphorus, we go to look at that, we have 1 phosphorus, just 1. Okay, so 1 phosphorus times its weight, which is 31, and we'll double check that one. Okay, we should double check all of them, but we'll make sure we double check that one. And then we have our oxygen, which if I go there on this problem right here, we have 4 oxygens. So we have 4 oxygens times the weight of oxygen, which is 16. And then we're going to put our equal sign in. Okay. So we might need our calculator, but let's go ahead and do this. Well, if I had 2 oxygens, that'd be 32. Double that, 64. So we know that that one's 64. This one's pretty simple, should be 31. This one's fairly simple, should be 12. And so now we just have to do this one over here. So I'm going to say it's 42. Okay, but let's double check that one, 42. Again, we should probably double check every single one of them. So we're going to take 3 times 14 equals 42. That one's good. And then do 12 times 1, I don't think 30. 1 times 1 we don't have to do. But let's go ahead and do the oxygen. 4 times 16 equals 64. That's good. So now all we have to do is add those up. So we're going to take 42 plus 12 plus 31 plus 64 equals 149. So the molar mass is 149 grams. And that's going to be of this substance right here. So again, I'm going to just go ahead and I believe I can still paste it there. And that's what it is. That's our molar mass. So 1 mole weighs that much right there. So let's go back and double check and make sure that we have these, that oxygen is 16, phosphorus is 31, hydrogen is 1, and nitrogen is 14. So we go back to the periodic table. We scroll up to the top. Okay. Let's see if we can get through this. Let's get all the way up to the top, and there we go. Then we can come back down to that one. So here it is. Our oxygen was 16, our phosphorus was 31, our hydrogen is 1, and our other one was, what was our other one? Oxygen, 14, I believe. So let's just go look at that. Oh, what was that problem? There we go, nitrogen. It was nitrogen, so it's 14. So we're good on all of them. So again, it never hurts to double check. So we're going to go ahead and get rid of this again and go right back to our problem. So we're down here. So this was correct, 149. So we're going to take this right here and we're going to copy that and we're going to paste it on the bottom. So we're going to copy it and we're going to paste it right there. Okay. So once I paste it right there, we know that we can get rid of our grams of ammonium phosphate. So we're going to strike through that. And we're going to strike through that. Okay. So once I do that, now I'm in moles of ammonium phosphate. So now I have to do my, as we look at it up here, we have to do our molar ratio. So we're going to say that we have our moles of this on bottom. So moles of this right here is 2 moles. And then we're going to zinc phosphate, which is this right here. So it's 2 to 1. So we're going to go ahead and put in our times and a line. And we're going to put this one on bottom. So we're going to put 2 moles, 2 moles of this, okay, of this right here on the bottom. We'll paste that there. And we're going to put down just 1 mole of this on the top. So we're going to go ahead and copy this. And we said we're going to put how many moles? 1 mole of the following. Okay. And we should probably underline this. So now once we get to this point, we can get rid of our moles of ammonium phosphate on each side. So we're going to go ahead and strike that through. As always, we need to make sure we get rid of everything that we can get rid of so we don't have to worry about it at the end. Okay. Now my problem is I have it in moles of zinc phosphate, and I need it in grams. So I have to use, if I go back up to my thing, I have to use molar mass. So we're going to come over here, and we're going to put down 1 mole of zinc phosphate. And I'm going to go ahead and take this off. That's strike through. Okay, what are we putting in the top? Well, we're putting on grams of zinc phosphate. And so now we have to go ahead and figure out how many grams are in 1 mole. I'm going to go ahead and I'm going to underline this one just to make sure. So where am I going to do this one? I'm going to do this one down over here. So let's do this one over here. And again, you can put it anywhere. So we're going to put in this. And so now I know we're figuring out the molar mass. So I have zinc, Zn. I have phosphorus, and I have oxygen. So there's only 3. 1, 2, 3. I see 3 capital letters. That helps me out. So how many zinc do we have? So if I go like this, I'm going to have 3 zinc. Okay. Phosphorus, I have 1 times the 2, so I have 2 phosphorus. Oxygen, I have 4 times the 2, so I have 8. So we're going to multiply those by the weight. And we know that this one's 16 from the previous one. We know that this one here is 31. But do you remember what zinc is? Okay, I can't remember what zinc is. So good thing we can go back to our packet, look at our periodic table. There's zinc. There's the number. It's 65. So let's get back out of it, and let's put 65 right there. So now all we have to do is put what they equal. So the only one that I know off the top of my head is this one. 32 times 2 is going to be 62. What about the rest of them? Let's just pull that up, and let's just say 65 times 3 equals 195. 195. Let's double check that one again. 65 times 3 equals 195. That's good. Let's do the other one. So 8 times 16 equals 128. That makes sense. 128. Let's do that one again. Okay. 8 times 16 equals 128. So there we go. So now all we have to do is add these up. So I'm going to go ahead and I'm going to put the molar mass equals those all added up. So let's go ahead and add those up together. So we have 195 plus 62 plus 128 equals 385. So let's put that in at 385. And again, double check it. So we're going to take 195 plus 62 plus 128 equals 385. That's going to be grams, okay, for our zinc phosphate. So I know that I can go ahead and just paste that down there. So there's our grams that we have. So we're going to take this number and place it right here. Okay, so we're going to put 385. Now again, can I get rid of anything? Well, I have moles of zinc phosphate here and moles of zinc phosphate there. So let's go ahead and get that straight through. So let's go ahead and strike that through. And let's go ahead and strike this one through. Now I'm left with grams of zinc phosphate. So I'm just going to pull this one over just because it's there. So I know that it's going to equal grams of zinc phosphate. So I'm going to go ahead and do my math. Again, we multiply the top, divide by the bottom, but we don't have to do anything with ones. So let's pull up our calculator again. And let's go ahead and use our calculator. So we're going to take 5, because that's our initial number. We're going to divide by 149, so we're going to divide by 149. Then we're going to divide by 2, right? That's on the bottom. Then we're going to multiply by 385. So we're going to multiply by 385. Oops, 385. Hit equals, and that's 6.459. So we're going to write that in here as 6.4559. Let's double check that number again. I always like to double check that number. Now again, we need to go how many significant figures, so I need to know I'm past that. If I go back to the original problem It was 3 significant figures, so my answer needs to be in 3. I have it in 4. So right now we know that we're going to round, but let's go ahead and double check this one again. So we are going to take 5 divided by 149 divided by 2 times 385 equals 6.4. Here we go. That looks good. And I could put a 7 there. I could put anything there. But since we're going to go to 3, that's where we're at right there. The 9 says we do what? We round up. So we're going to get rid of that. Get rid of put the 6 there. There's our answer. So we're all done. All we have to do at this point here is going to highlight the answer and say, there's our answer for this problem, for problem number 5. Great job. As always, go Mohawks. Nelson out.